Unit 2 Logic Gates and Boolean Algebra 2.1 Logic Gates. When we think about the logic gates, we discuss about in the lower grade. A digital electronic circuit operates with voltages of two logic levels, namely logic low and logic high. The range of voltage corresponding to logic low is represented with 0. Similarly, the range of voltage corresponding to logic high is represented with 1. The basic digital electronic circuit that has one or more inputs and single output is known as logic gates. Hence, the logic gates are the building blocks of any digital systems. We can classify these logic gates into the following three categories: basic gates, universal gates, special gates. The basic gates are AND gate, OR gate, and NOT gate. An AND gate is a digital circuit that has two or more inputs and produces an output, which is the logical AND on all of these inputs. It is optional to represent the logical AND with the symbol dot. Here A, B are the input and Y is the output of two inputs. A and B are the output. If both inputs are 1, then only the output Y, A and B is 1. For remaining combinations of inputs, the output A and B is 0, or you can say Y. An OR gate is a digital circuit that has two or more inputs and produces an output, which is the logical OR of all those inputs. This logical OR is represented with the symbol plus. Here A, B are the inputs and Y is the output of two inputs OR gate. If both inputs are 0, then only the output Y is 0. For remaining combinations of inputs, the output Y is 1, which means Y is equals to A plus B. A NOT gate is a digital circuit that has simple input and single output. The output of NOT gate is the logical inversion of input. Hence, the NOT gate is also called as inverter. Here A and Y, which means A in prime, are the input and output of NOT gate respectively. If the input A is 0, then the output Y, which equals to A prime, is 1. Similarly, if the input A is 1, then the output Y, which equals to A prime, is 0. NAND and NOR gates are called as universal gates because we can implement any Boolean function which is in sum of products formed by using NAND gates alone. Similarly, we can implement any Boolean function which is in product of sums formed by using NOR gates alone. NAND gate is a digital circuit that has two or more inputs and produces an output, which is the inversion of logical AND of all those inputs. Here A, B and the input and Y is the output of two inputs in NAND gate. When both inputs are 1, the output Y is 0. If at least one of the inputs is 0, then the output Y is 1. This is just opposite to that of two inputs AND gate operation. NOR gate is a digital circuit that has two or more inputs and produces an output, which is the inversion of logic or of all those inputs. Here A and B are the inputs and Y is the output. If both inputs are 0, then the output Y is 1. If at least one is the input is 1, then the output Y is 0. This is just opposite to that of two input OR gate operation. EX-OR and EX-NOR gates are called as special gates because these two gates are special cases of OR and NOR gates. The full form of EX-OR gate is exclusive OR gate. Its function is same as that of OR gate, except for some cases when the inputs having even number of ones. Here A, B are the inputs and Y is the output of two inputs EX-OR gate. The truth table of EX-OR gate is same as that of OR gate for the first 3 rows. The only modification is in the 4th row. That means the output YY is 0 and instead of 1. Who both the inputs are 1 since the inputs having even number of ones. The full form of EX-NOR gate is exclusive NOR gate. Its function is same as that of NOR gate except for some cases when the input having even number of ones. Here A, B are the inputs and Y is the output. The truth table of EX-NOR gate is same as that of NOR gate for the first rows. The only modification is in the 4th row. That means the output is 1 instead of 0 when both the inputs are 1.